All right. Hello, everyone. Welcome to today's stream where we have my dear friend Ashutosh here again. And today he will be building a sentiment analysis using Python. I have no idea what that is. I will be here with my notebook and then I'll be taking some notes on that. So before we start the coding demo, um, Ashutosh, please can you tell us a bit about what a sentiment analysis is?
Sure. And first of all, thank you so much, Sophia, for having me here again. It's so much fun to be here with you. And this is the second time, and I'm sure that uh, I'm going to love it. And the watcher is also going to love it. So, all right. Y- on your question on what sentiment analysis is, it's basically um, trying to understand what the mood of the person is, or whoever has written the text, right? What do they think? Yeah, is the text kind of positive? Is the text leaning towards negative, feelings, emotions? um, Essentially analyzing and understanding what kind of sentiment a particular text has. That's kind of
Okay.
like the overarching idea of doing sentiment analysis.
All right. Okay. So it's like finding out if feedbacks are positive or negative. Is that it?
Yeah, yeah. That's kind of one of the use cases where sentiment analysis is used, definitely for feedback, to understanding feedback. And I have seen that a lot of companies, they have these chatbots on their websites, right? So if you visit a website, you must have seen a chatbot on the down right corner. You click on it, it pops up, and then you can basically chat with it.
Yeah.
What happens is, especially with big companies like Amazon, I don't know, Walmart, or things like that, what they do is they store all this chat data, right? You and me, whenever we chat with the chatbot, they will store this data, and later what they will do is they will use that data, the chat history, to kind of understand if our issues were solved. What kind of language did we use, what kind of language did the chatbot use, and was it positive experience, was it a negative experience? All these things are kind of implemented and automated using this sentiment analysis behind the scenes.
Oh. Oh wow. Okay. Wow, that's really really cool. And I think I kind of now get the whole idea of what we are going to build today. Sorry, what you are going to build today. All right. So the let's start the demo. Uh,
Perfect. All right, so
so
let me just go ahead and switch to the tab. All right, so what we're going to do is we are going to see two ways of doing sentiment analysis today. All right, so the first one is going to be very easy. The second one is also going to be very easy, but it's going to kind of build up on what we do in the first one. So if you're not, are you already familiar with this interface, Sophia? What
uh,
this is?
this is Google Colab, right?
Exactly. Yes. Yeah.
Yeah.
So as a data scientist, as a machine learning engineer, um, this is kind of one of my favorite interfaces to use for programming in Python. And essentially, eh, interacting with data, because as a data scientist, as a machine learning engineer, we have to do a lot of iterations, right? uh, do a lot of trial and error with the code and see which one works best, and this kind of allows you to do that very easily. It's very modular. But yeah, so we're going to use Google Colab today, and it's going to be fun. All right. so enough of talking.
Yeah.
First thing, what we're going to do is we are going to use this Python library called text blob. Okay, so we are going to install that, which we can do that with an exclamation mark pip install um, text blob. All right, so we are going to install this, and we are going to hit Shift Enter, which is going to run this cell. And as soon as it runs this cell, it creates another cell for us. So it checks and it installs, and while it installs, oh, we're done. So it installed text blob, and it turns out that it's already installed in this environment. For you, it might be installed, it might not be installed. So it's always a good habit to install these libraries explicitly. And that what we're going to do is we're going to import that. So from text blob, we are going to import um, text blob.
Okay.
So we import this. And again, with text blob, we are also going to use data classes because we need to store data um, uh, in a basically Pydantic way, kind of. So, so we are going to import from data classes, import data class. So for those of you who have idea, who have heard about like data classes, who have used data classes, already know what it is. But for those of you who don't, it's basically it allows you to use any class for just for storing attributes. Kind of like a model, like for kind of like a data model. So it gives you this decorator data class, and when you apply this decorator on any class, that class is essentially a model, right? So we can write class and sentiment, right? So this class will be named sentiment, and then we are going to have essentially two attributes. So we are going to have the sentiment itself, which is going to be of string type, and then we are going to have a score, which is going to tell us um, how much does this sentiment kind of leans toward positive or negative, which will be of type float. So we just imported text blob, we imported data classes, and we created our first data class. And we hit Shift plus Enter to run this cell. Now what we're going to do is we are going to have uh, create a method. So what we're going to do
Okay.
is we're going to write def, and then we're going to write this function get sentiment, and we are going to have it. So we're going to pass the text itself, the text for which we want the sentiment, right? Um, which will be of type string. And then we're also going to have a threshold. So the threshold, what it's going to tell us is, what is the sensitivity of our sentiment analysis bot, if you want to call it, right? So
Okay.
um, let's say if you want the sentiment analysis bot to be very sensitive between positive and negative, you can set the threshold low, and it's going to be, it, basically it's going to tell most of the things as either positive or negative. It's not going to tell a lot of text, it's not going to classify a lot of text as neutral. But if you give a threshold, a higher threshold, then it's going to, you're going to have to be a lot more positive than before to be to for it to be classified as positive or negative. We'll see what I'm talking about in just a moment.
Hmm.
uh, and this function is going to return our data class. All right, so what we're going to do in this function is it's going to take the text that you enter, right? And it's going to take that text, and it's according to the threshold, it's going to classify that text as either positive, negative, or neutral, right?
Okay.
So based on whatever you type. So it's going to take that and then classify accordingly. So let's do that. So what we're going to do first is we are going to get the score. So the oops, sentiment score is going to be, now we are using the text blob library that we imported earlier. So text blob, and then we are going to pass the text that the user entered, which we got um, through this parameter here. And then what we're going to do is we are going to call the method sentiment dot polarity. So essentially what we're doing here is we are using this text blob library to get the polarity of how much positive or how much negative the particular text that we enter is. So we get this using text blob dot sentiment dot polarity. And then what we're going to do is a simple if else, which is
Yeah,
if.
sorry, I do have a question. Can I ask while you code, or do I
Sure,
wait
yeah, yeah.
at the end? All right. So, what exactly is polarity?
Right, that's a great question. So uh, let's try and print it here and see what it is. So it's basically a score between +1 and -1. All right,
Okay.
so it looks kind of like this. Oops, sentiment score. All right, and then let me actually just pass the text here, which is I am very happy today. All right, so what this sentiment score is going to be is according to whatever the sentence that you or the text that you enter here, it's
Okay.
going to calculate the polarity of this sentence, which is between -1 and 1, where -1 being the most negative and +1 being the most positive. So in this case, it should be closer to 1 than to -1, right? So if we print this, you see that the score gives a perfect 1, which means that this text is very positive, right? Now let's say if we change this to I am feeling sad, right? For example, then this is going to be closer to -1, which is -0.5, right? So this is kind of what this polarity uh, attribute does here.
I see. I see.
Yeah. So we are going to use that to kind of to show how negative or how positive or basically how neutral. If it's closer to 0, that means it's neutral. So between these three um, categories, which one does our text belong to? So hopefully that was easy enough to understand.
Yeah,
um,
it was.
cool. Okay, so now what we're going to do is according to this sentiment score, we are going to classify our text as positive, negative, or neutral, right? So it's going to be a pretty simple if else statement, which is, if the sentiment score is greater than or equal to our threshold, right? So we are going to be able to set a threshold above which we classify the text as positive, then below which we are going to classify the text as negative, and in between, where if the score is somewhere in between those two, then we are going to classify it as neutral, right? So sentiment score, if it's greater than threshold, it's positive. If the sentiment score is less than negative of threshold, then it's negative. Otherwise, it's going to be neutral because it's going to be in between negative threshold and positive threshold. So it'll be even more clear when we use this method. So again, Shift Enter is going to run this cell, and now we have access to this method, this function. Now, to be able to play with this, I'm just going to put this in a while loop, right? So we're going to do while true, and let's say we are going to get the text from the user. So text equals input, and which is going to show this prompt for the user to know that it's a text that you want to enter. And then um, let's say if text equals exit, then we are going to break. All right. Now what we're going to do is we are going to call this method and pass the text that the user enters. So we call this get sentiment method, we pass the text that user enters, and then we are going to set the threshold. So let me do something like this so that it's easier to understand. All right. So by doing this, we get the sentiment, right? So remember that this function, it returns the data class itself, which we created here, right?
Yeah.
So now we have access to the object, right? Now we have access to the sentiment object. What we can do is we can print sentiment dot sentiment, or you know what? Let's just change this to, I don't know, mood, which makes it much easier. Uh, okay, sentiment dot mood, and then we also have sentiment dot score. Okay, so let's see how this works. So I'm going to run
All
this,
right.
and now this loop is running, asks user for a text. So let's say um, I ate something and it was horrible. Okay, so let's see how it does with this. Um, ooh, okay, so there is a problem here. Let's see. Sentiment object has no attribute mood. Oops. Yeah, because I have to rerun this cell to make the changes, and then
Oh,
let's.
so you need to rerun every single cell.
Not every single cell. So okay, so this is actually something um, which does not make sense initially, but it makes sense when you think about it, right? So, for example, like if I made a change here in this code,
Yeah.
and then I go ahead and run any other code which kind of depends on this code does not know that this change has been made, right? Until and unless I rerun this particular cell, because when this cell was created, when this code was written, at that time, this class had some other attribute, right? So when we access, let's say, sentiment.mood, and here this attribute was sentiment, then it's going to say that mood does not exist because we did not tell the interpreter that, hey, I have changed this to mood. I just changed it in text. It's kind of like how you save and run the file again in Python when you write it, right? A .py file.
Yeah.
Whenever you make some change, you have to save and run it again, right? So it's kind of similar here. If you make any change, you have to run that cell again for any other
Uh,
cells that depend on it to know what's going on.
oh, I see. So there isn't like an auto save where once you make a change, it automatically saves and you don't really need to rerun that.
Um, okay, I don't think so. I have not tried it yet, but I may be wrong. But I don't think so that there is an autosave here, functionality here.
Mhm.
Although it could be, I'm not sure actually. It does autosaves in sometimes. So you see here it says all changes saved. So I believe
Yeah.
whenever you run a cell, it saves, auto saves. But until you don't run the cell, it's not going to save. Something like that.
I
But
see. I
just
see.
to be sure, it's good to run the cell wherever you made the change. Um, but yeah, yeah. So yeah, thanks for the question. That was a good question actually. So all right, so let's try this again. I ate a hot dog and it was horrible. Okay, so it recognized that this is a negative text, right? So it prints negative and it also shows you the score. Uh, let's see. Um, I love the weather today, right? And it recognizes this as positive. Now, we can actually change this. So, you remember we added this threshold, right?
Yeah.
So, right now, what it's doing is it's whatever is whatever text that gives a polarity score, the sentiment score of greater than zero point 0.2, it's going to assign positive to it, right? If it's less than negative zero point 0.2, then it's going to tell that this text is negative. So we can change that.
Okay.
If we change this to, let's say, zero point 0.7, right? Now, if we enter the same text, oops, and I need to actually rerun this cell. So I need to stop this, rerun this cell, right? Now remember, last time it was zero point 0.5 and it said that it was positive. This time, I think it's going to say negative. Oh, it says neutral, right? Oh yeah, because anything between zero point 0.7 and negative zero point 0.7 is neutral now, right?
Oh,
So according to this, um, simple if else statement that we have written, anything that's greater than the threshold, which is anything that's greater than zero point 0.7, is going to be positive. Anything that is less than negative of threshold, that means anything that's less than negative of zero point 0.7, which is between negative 1 and negative zero point 0.7, that is going to be assigned negative. And anything that is between negative zero point 0.7 and zero point 0.7 is going to be neutral. So that's why this got classified as neutral, right? So you can actually
yeah.
change the threshold, and it's up to you how sensitive you want it to be. So if you want it to be positive only for like extremely positive statements, uh,
Okay.
which is going to be above zero point 0.7, then you can change this threshold to something greater. If you want it to be extremely sensitive, where it says that any slightly good statement is also considered positive, then you can lower this threshold, and you'll get that output. So that's kind of an overview of how easy it is to do to do sentiment analysis today, right?
Yeah.
This library text blob, it uses another library in the backend, which is called um, NLTK, which you can see here, right? NLTK is kind of like the OG library. Everyone who writes these sentiment analysis um, feature, whoever adds this feature into their chatbots or um, any other applications that they're building directly, they're going to use NLTK, and this is one of the best libraries for doing this kind of job. Um, Now, text blob actually makes it easier for you to do sentiment analysis and a lot of other tasks, but it's not as flexible as
Okay.
using NLTK, right? But it does the job right now. So we are able to get positive, negative, and neutral um, sentiment. So you can use this directly into your any application that you're building. If you're building a chatbot which is user facing, and you want to understand how users are interacting with your chatbot, you can use this behind the scenes, and you can get the um, uh, overall sentiment of how users feel about it, or even how, while you are collecting feedback from the users, right? You can have this uh, run run on all of your feedback data, all the text, and you can see, like, overall, what do the users think about your product and things like that. So this is pretty handy. um, but yeah, this is the first way, and this is a much easier way. uh, but there is another way of doing this, which involves using um, the very, what should we say, um, popular term nowadays, which is transformers. So you can do this using transformers as well. Right now, what this text blob is doing is directly modifying the text itself, and trying to do some manual transformations on the text, and then it kind of gives you this score.
Oh, yeah. I know that in our last stream you talked about transformers,
Hmm.
and I I genuinely can't remember what transformers are. So
Right.
for someone that did not watch the last stream and is very new to this, can you please explain what transformers are briefly?
Yeah. Sure. Yeah. So, okay. So transformers are this. It's basically an architecture which is used nowadays in all of these, chatbots that you see online. Mostly companies like OpenAI, Anthropic, Google, even Amazon, Microsoft. All of these companies are using Apple in their AI products, and this architecture is the kind of the brains behind ChatGPT, behind Claude, behind Google Gemini, and a lot of other um, these AI enabled chatbots that you see and interact with online today. So it's basically just an architecture which takes any text as input and does some modifications, and uh, it can either classify the text or it can generate new text, and that's how you use like ChatGPT. So it's kind of like the brains behind whatever you however you interact with ChatGPT, the way that it generates those text. Transformer is kind of like the brains behind all of that.
Oh, I see. Oh, that's pretty cool. So, are you going to show us how to build this analysis using transformers too?
Yes, and it's pretty easy. It's
Awesome.
not like it's not going to be a lot very difficult. So it's going to be pretty easy.
Oh,
Um, so let's go ahead, and actually, I'm just going to. You can either create a new, a new notebook, right? Using the new notebook in Drive option, and it's going to just open a brand new notebook for you. I'm just going to add some cells here, and it's going to continue from here. All right. So now what we're going to do is we're going to use a transformer model. So transformers are actually there are two kinds of transformer models nowadays, which are used uh, all around this AI world, basically. Uh,
okay.
the first kind of transformer model is based on BERT, right? So BERT uh, is one of the transformer models. The another transformer model is GPT, right? So
That I
GPT,
know.
yes, exactly, right. So GPT in chat GPT is basically generative pre-trained transformer. So this is the full form of GPT, and you can see that it
Okay.
has the word transformer in it, right? So it kind of like screams at you and it says that, hey, I'm using transformer behind the scenes. uh, and BERT full form is again it's bidirectional encoder representation from transformers. So again, this also has transformers in it, right? So these are kind of like the main two kinds of transformer models that we have today. GPT is mainly used for um, natural oops, natural language oops, generation. So what it means is these kind of transformer models, they are used to generate the text. So what happens is whenever you interact with ChatGPT, you enter some text in the chat, right? What it does is it takes that text and sends it to the ChatGPT model. What the model does is it takes that text and it kind of starts predicting what the next word is going to be. So it's
Okay.
trained in a way where it has to generate the text. So whatever the input that you give, it basically what it does is it kind of predicts the next words that's most probably are going to follow whatever the input that you gave, right? So it does not really come up with something. It does not really think per se. But what it does is,
Yeah.
according to whatever the data it was trained on, it uh, generates the next most probable uh, text that's going to follow your input. So that's how this natural language generation works. It generates the text, and that's why its name is also generative pre-trained transformer. um, BERT, on the other hand, it is it does the task of natural language understanding. So GPT actually, it works only from uh, left to right. That means that whenever it takes any text that you enter, it's going to read whatever the text that you enter from left to right, just how humans read the text, right?
Oh, yeah.
But BERT, as it says, it's bidirectional. So what it does is it reads the text from uh, both sides, right? So uh, both right to left and left to right. So it reads the text from both sides, and in that way it's able to understand even more. So it can understand, its ability to understand the language itself is much better than the ability for GPTs to do that, right? So we are going, in our case, what we're going to do is we are going to use BERT. We are not going to use GPT, because what we have to do is we have to get the sentiment of the text. And in order to get the sentiment of the text, you need to understand it much better, right? So
I
that's why
see.
we are going to use BERT in our case and not GPT. So let me actually convert this or something. Yeah, I'm just going to add this here. All right. So these are kind of the two things. All right. So now let's look at what data sets we are going to use. All right. So let me open that really quickly. So if you open this data set, like this. So this is the link to the data set that we are going to use. Um,
Okay.
let's see, is there any way to share this?
Yeah, I think you can share it on the private chat and I would include it in the description and in the chats.
Okay, okay, cool. Let me share this. All right, so this is the data set that we're going to use. Um, and in just a moment, I will show you what this data set looks like. Uh, all right, so what we're going to do is we are going to first, to use this data set, we have two ways to do that. Either we can go to Kaggle, we can download this locally, and then we can
Okay.
upload this data set manually to Google Colab. um, and it's going to be available only for this session. If you close this session and if you restart this session, that data is going to be gone, and then you'll have to again upload the data set. It's not a big data set. I think it's like 5 to 10 MBs, which is okay. But what we're going to do is we are going to directly use the data set from this link instead of downloading it. So we are going to import uh, Kaggle Hub, which is already installed in Google Colab, so we don't need to install Kaggle Hub. But if
Okay.
you're following this, in your own system locally instead of on Google Colab, you can do pip install Kaggle Hub and then import Kaggle Hub in your Python. So we're going
Yeah,
to
can
import
you
Kaggle.
scroll up so that the
Right.
down would be more visible? No, like scroll up so
Oh,
we
right.
yes, yes, that's perfect.
Cool. Yeah. Thanks for that. So, all right. So we are going to import Kaggle Hub, and then we are going to download the data set. So C file path is going to be Kaggle Hub dot download. Oops. dot dataset download. And what we're going to do is we are going to pass
The
the
URL.
not the entire URL, just like from the username till oops, from the username till this end of the URL. So this is the username Odinson, I guess, and then from there till the end. And that's what we're going to paste here. And then let's just print the file path and we'll see where this downloads. So,
Yeah, I think I will be switching the layout to the other one that expands more because it's a bit
mhm,
difficult on my end to see this. Okay, all right,
mhm.
let's continue.
All right. So we'll run this and it's going to download the dataset and it did it pretty quickly. This was some 18.5 MB. And then we print the file path where it downloaded and we can see that it downloaded the dataset in this folder, which is folder 756. So now what we're going to do is uh, we will have to install a bunch of different libraries. And these libraries are transformers, which is a great library to interact with transformers. Torch, which is for using PyTorch as a framework of choice, and NumPy and Pandas are essential to deal with numbers and any kind of tabular data. So
Yeah,
NumPy.
so
Mhm.
yeah, I have a question. So does PyTorch still handle data and numbers? Because I know of NumPy and Pandas, but I'm not too familiar with PyTorch.
Right. So PyTorch actually it's a high level library which kind of like makes it easier for you to um, do all this process which is involved in doing data science, right? So
Okay.
what it does is it gives you tools to set up a pipeline, and within the pipeline you can do um, data preparation, which is cleaning the data, working, handling data, missing data, and things like that. Then passing this data to the model, and then getting the output from the model, and then storing it wherever you want. So this entire pipeline, it basically PyTorch makes it easier for you to implement all of that. So that's why we're going to use PyTorch. PyTorch,
Mm.
under the hood, whenever it has to do any kind of you know operations under the hood, it I think it still uses NumPy for any kind of mathematical operations. So it's still good, although by installing Torch I think it does automatically install NumPy, but it's always good to be explicit and install the library anyway. So again, transformers, Torch, NumPy, Pandas. I hope that answers your question, Sophia.
Yes, yes, that did.
Cool. Cool. Okay, so we're going to install this, and it might already be installed. And we see that, yep, for me it was already installed, but for you it might not be. So it's good to do that explicitly. And then we are going to see what files are present. So we downloaded the data set into this folder, right? So this is the folder. I'm just going to do
Okay.
what I'm going to do is I'm going to check what are the files in this folder. So ls exclamation ls. Basically what happens is this cell is for Python coding, right? But whenever you put an exclamation in the beginning, you can actually use this cell for writing um,
Bash
essentially
scripts.
bash scripts. Exactly. So in this case we're using ls to see what kind of oops, just gonna copy that, what kind of files are present in this directory where we downloaded.
All right.
So I'm just going to run that. And I see that there are a lot of files in this folder, right? So we downloaded all of these files. Now, this data set is what this data set is for is it's the data set of top 20 Play Store app reviews. So these are the top 20 Play Store app reviews, and I believe that it is automatically the person who maintains this a data set. They scrape the Play Store regularly. So this is, I think it's up to date. So these are the top 20 Play Store apps, and each of these files, the CSV files, is going to contain the review, right? The app review of this
All
particular.
right.
So for our purpose, we are going to use just one of them. We're not going to use all combined just because it's going to be too much text, and it does take some GPU to do the transformations that we are going to need. So let's say, um, let's choose any one of these. What do you say, Sophia? Which application do you want to go with?
Let's try Candy Crush.
Candy Crush. Yes, perfect. So what we're gonna do is, we are going to import pandas as PD. Now this is, you don't really need to do import pandas as PD. You can just import pandas, but this is kind of like best practice. I mean, not really best practice, but it's kind of like now the way that people do this is the import pandas as PD because it's makes it much easier to use pandas, right?
I
Instead of writing pandas.
see. Yeah,
Uh,
because I've seen that line on a notebook before, and I was a bit confused. Like, why not just import pandas the way it is, and then in the code you can just do pandas dots if
yeah,
you want to call a function within that. So,
yeah, it's kind of like an unspoken rule now in the data science
yeah.
world. But if you want, you can just use pandas. It's not a big deal. Um, but yeah, so we are going to use if import pandas as PD, and then it gives you access to kind of dealing with any data that is in tabular format. So all of this data in CSV can be converted to a table, right? So that's why we're going to use pandas, and then it conveniently uh, gives you access to read CSV file, read CSV method, and then you can just pass whatever the file name that you want to read. So in our case, what we're going to do is we already have the file name stored in this file path variable, right? Remember when we downloaded this, we have the directory. So
Yeah,
we use that, and then we need to select a particular file. So we're going to use plus, and then whatever the file name we have to pass. So we're going to use Candy Crush Saga here. And we need to also add a slash in the beginning because this is technically a directory and we are going within that to access this file. So if you do that and you run this, I mean, you don't see any output, but if we do df dot, or if we just write df, which actually stands for data frame, which is
yeah.
a terminology which is used in pandas, which is, any data set which is read into a table is called a data frame. So if we just run this, you can see this is what we have. We have the data set which is loaded into this data frame from this CSV
That's
file.
cool.
Yeah. So we have the review ID, we have the content, which is the text itself, the review, and then we
Yeah,
have the score, which is, it ranges between 1 to 5, the 5-star review or 1-star review, uh, whatever people provide. So, all right, we have this data set loaded. Now, what we're going to do is, since this is like 10,000 rows, this is still a lot of data for us to, train our model on. So, what we're going to do is we're just going to uh, update this data frame by choosing a smaller sample from this. So
okay.
you can use df equals, which is going to update the data frame. to df dot sample, right? Now, what this sample function does is it basically randomly samples or randomly picks any number of examples that you wanted to pick. So in our case, let's say we want to pick randomly 500 examples from these 10,000 uh, reviews. So as it says, if you hover over this, it says, return a random sample of items from an axis of object, which is basically what we're doing. And if we see now, right, if we see now it says that, hey, there are 500 rows, and you can see that it randomly chooses any 500, right? So here we start from 0 1 2 3 4, and it goes on to 9999. Here you see that it randomly chose 9699 first, and then 1047, and so on and so forth. So basically these are like randomly chosen.
All right.
And we have like a variety of different scores as well, which is good. So cool. So now we have our data, which we will work with. Now what we're going to do is, remember we downloaded the transformers library, right? So what we're going to do is from uh, transformers, we are going to import pipeline, and this is what we're going to use to kind of bring everything together and run everything in kind of like a one flow. And also we are going to import the BERT model, which we are going to use, right? So we are going to specifically use a model which is called the distill BERT model. And again, let me actually share the link for people who are curious to see where the model lives. This is the Hugging Face link for the model. If you want to go check it out, you can just follow this link, and you will reach the model card where they explain everything related to this model. Who developed this model, what is the model type. It does text classification, its license, and some example code snippets as well. So there's that. But anyway, so we are going to use that model, and to do that, that model name is Distilbert, so which is kind of like a branch off of the main BERT model. Uh, we're going to use Distilbert tokenizer, which is a tokenizer model, and then we are going to use Distilbert for sequence classification. So uh, in just a short while, I will explain you why these two things are different and not just one single model, right?
Okay.
Um, but let's just go ahead for now and just understand. So now we have to load the tokenizer and the classification model. So we will load the tokenizer into the tokenizer variable, which is distilbert tokenizer dot, and then we are going to use the method from pre-trained, because we don't want to train this model from scratch. We want to use this model which is already trained by in this case Hugging Face. They have already trained this model on huge amounts of data. We just want to use this model for classifying positive, negative, and neutral, right? So we don't want to train this model from scratch, because that's going to take lots of resources, lots of time, and possibly lots of money. So we want to avoid that, right? That's why we are going to use the pre-trained model. And we are going to then pass whatever is the model name. Now, if you open the link that I shared, um, you are going to see something like, just give me a sec. Um, oops, just let me share my screen again. Mm, entire screen. Yes, let me share the screen. All right, this is much better. So this is where I'm going to open this and paste this. All right, so you guys can also see what I'm talking about. All right, so this is what the model card looks like, and this is the name of the model. Um, Distilbert slash, this is the entire name of the model. So you can see this. There's an option to copy this. You can copy this name of the model and directly paste it here. Right. So what this does is it's automatically going to access that link and download this model instead of you going to you having to do that. Manually. All right. So we have the tokenizer for this model. We need the model as well, right? So this is going to be, instead of Distilbert tokenizer, now we are going to use the Distilbert sequence classification. Now let me explain what's happening here. So for any kind of um, model that works with text, since computers only understand zeros and ones, right? I mean, it's
Okay.
just zeros and ones that's going on in the memory. They cannot really understand the human written languages, which is any kind of text. So what you have to do is we have to tokenize the text and then convert it into these numbers, which the numbers are something that the computers can understand. And then it works with these numbers and then converts these numbers back to text. And that's what you see when you chat with ChatGPT, for example, right? So tokenizer is a model which takes the text, whatever the text you enter, and it breaks the sentence down to words. I mean, it's not really words, it's parts of words, but let's for now let's just assume that it breaks a sentence down to separate words. For example, in this case, right, this says best game ever, best ever game to be played, enjoy my
Yeah.
best. It's going to take this sentence and it's going to divide this sentence into multiple words. So this word is going to be one token, ever is going to be another token, and then game is going to be another token, to another token, be another token, played another token, then comma another token, and so on, right? So each word, each punctuation is going to be a separate token, and then that separate word is going to get assigned a number, and that number is what these models work with. So tokenizer is really important, right? So
I
we are
see.
going to use this tokenizer, and then we are going to use this tokenizer to convert all of these texts into words, and then those words into numbers, and then those tokenized words or tokenized reviews are what we're going to pass to this classification model, right? So let me run this cell, and it's going to download the tokenizer and the classification model, both of them. It's going to take some time. So in the meanwhile, let me actually go ahead and create the pipeline. So I'm just going to name this pipeline NLP, or you know what? Let's name this sentiment.
Can you scroll up? It's
Sure.
yeah. Also,
Yeah. Thank you. So we are going to name this pipeline sentiment analysis. Oops, pipeline. All right. And we are going to use the pipeline that we imported earlier from transformers. And what we're going to do is we are going to pass the name of this pipeline, which is, you can name it anything. Since
okay.
since we are doing sentiment analysis, I'm just going to write sentiment analysis, um, and we have to pass the model, right, which is nothing but our model here. So I'm just going to say model equals model, and we also have to pass the tokenizer. which is this tokenizer right here. Right. So again, uh, what we're doing here is, so what we're doing here is, uh, first we downloaded the tokenizer and the model, both of them. Now what we're doing is we're creating a pipeline, and what this pipeline actually does is it kind of tells, um, it sets everything behind the scene, what's going to happen. So basically, what its setting is, the tokenizer is going to take the text, it's going to convert it to the numbers, separate words, and then those words are going to be converted to numbers. Those numbers are going to be then sent to the model. The model will then generate the response. It's going to generate separate words. Those words are then going to be combined together into, um, you know, sentences, and then that is what is going to be the output. So this
Oh, I
all of
see.
this pipeline is handling. So that's why we're using,
Oh,
right? Um, all right. So we have the pipeline set up, and now what we're going to do is we are going to run this. So we have the pipeline set up, and now we are going to load the texts from this, data frame. So to do that, we need to access this particular column in this table, right? Because this is the column that has the text. So
okay.
to do that, we do data frame, whatever is the name of this data frame, which is just df, right? Data frame, dot, since the name of this column is
Content.
content, right? So we're going to do data frame df dot content, and then what we're going to do is dot values. So it extracts all the values from the content. Now it does that, but it's going to have this as a two-dimensional matrix, right? What we want is a single list of all of these texts, which can be passed to the model, so that one by one we can get output for each and every text, right, in a list.
Okay.
So that's why we are going to call another method, which is to list,
To list.
right? Which is going to convert everything to a one-dimensional single list.
I
So
see.
let's see that and how the texts look, right? So you see how each one of them is extracted, and you see the comma. So this is a single list of all of these, texts. I'm just going to hide this because it's a lot of text.
Well, and then another thing I noticed in Notebook from your demo is that you
Right.
really don't have to use the print statements to print out something. I noticed that here you just mentioned the variable and
Right.
you ran it and it's showed the results. Usually in a Python file in VS Code, you will need to use the print statement like print Texas, print DF, print this, print that, which is really cool.
Yeah. Yeah. Exactly. Yes. But I believe it's also possible to do it in the in the Python files as well.
Oh,
So
really?
yeah, maybe try having one of these variables, and it just prints that.
I'll
Um,
definitely try it.
yeah, but you can definitely like do print and then texts, and then I think it's going to print this in the list itself. So this is much easier to read, right? uh, you can clearly see that. Oops, go. You can clearly see that this is like a list, which is separated by commas. Uh, but what happens is when you use this print statement, right? So the
Okay.
print statement also has its own like uh, magic method, right? I believe that you know about the magic methods, right? So
Yeah,
uh, the print statement also has its own like uh, implemented REPR or wrapper method, which kind of like makes it easier to format all of this. If it's a list, it's going to be formatted like accordingly, and that's why it's easier to see it using print statement. If I don't use the print statement, then it's going to be just like, a list, and it just directly shows it how it is. There is no like formatting going on here.
I see.
Yeah. So that, yeah, oops, that is something that is interesting. But yeah, that's a good point to bring up. Let me hide this output. Okay, so we have the text. Now what we have to do is we have to get the results, right? So we have to pass this text. We have to pass this text to this pipeline, right? The pipeline that we created. And this
Yeah.
pipeline will do all of those things. It will pass the text to the tokenizer, then the tokenizer will pass the text to the model, then our model will give the output, and all of that this pipeline will handle. So let's do that. We are going to get the result. Results equals sentiment analysis pipeline, and we are going to pass the text to this pipeline, and we're going to get the results, right?
Okay.
And let's see what the results look like. So let's run this, and it's going to run on GPU. So it's going to take some time if you're running this locally. Remember that when we are using um, a collab, we already have access to some RAM, right? So directly it loads everything, all of this text directly into the RAM. So if you have lesser RAM in your system, that's also going to affect the performance.
Oh, yeah. So, I really have to ask because I always pretend to know. What really is the difference between GPU and CPU?
Right. That's a really good question. So CPU. Okay. So how can I explain this? So CPU is like designed to do a lot of different tasks, right? So a
Okay.
CPU is able to run this, this browser. The CPU is also able to run Microsoft Word. A CPU is also able to run, 100 different things, whatever the application that you have installed. And the CPU is also able to run any kind of operating system that you install on it, right? So CPU is like a very general purpose processing unit. It can do a lot of different things, but it can not do all of them very fast, right? So if you are doing a lot of different things, sometimes you also might notice that your CPU utilization might go up to 100%, right? If you have, let's say, a lot of different tabs open, or if you're like watching a 4K video and then on the side you're also like editing a video and things like that, your CPU utilization goes like 100% up. And
Yeah.
it's able to do a lot of different things, but it's not able to do one single thing very well, right? So that's kind of like the bottleneck of a CPU. GPUs, on the other hand, are designed to do like one specific thing, which is they're designed to do matrix multiplications. So huge matrices, like n-dimensional matrices multiplied by n-dimensional matrices, it's really good in doing that. And the reason it's able to do that is because when GPUs first were designed, I think they were first designed by NVIDIA. So they designed it for gaming, right? And in gaming, what happens is every pixel that you see on your screen, right, that pixel has some information, and it's visualized using matrices. So there are lots of like shapes and polygons which are being rendered in real time, and for them to update as your character moves into the game, it needs to do like a lot of interaction between those pixels, and that's where lots of matrix multiplications need to happen, and that's how like GPUs came into being. But later, like in early 2010s or mid 2010s, like around 2014 2015, people realized that GPUs are good for doing machine learning and deep learning things as well, right? because machine learning and neural networks, they also have to perform a lot of matrix multiplications. And that's how, machine learning engineers and data scientists started using GPUs. um, and it kind of like, really propelled the field forward, uh, instead of just using, CPUs before that. But yeah, that's kind of like the main difference. That was a very long-winded answer to the question. But yeah, the main difference is GPUs are made to do just one specific thing, and they are very good at it, whereas CPUs are made to, do a lot of different things, and they're very good at doing that, but they're not good at, doing one specific thing. Um,
I see.
so
Wow.
yeah,
That
so
was a perfect answer. I definitely understood that.
perfect, perfect, awesome. Uh, all right, awesome. So we see that we have some error here. Text input must be of type string. Hmm. Okay. So let's see what the problem is. We have df content value. Mhm. Okay. Or this string. Hmm. So now, I kind of know, or I think I know what the problem is, but I just want to
Okay.
show you this one more feature, which is a very cool feature
Right.
of Colab. So since Colab is a product from Google, we have access to Gemini as well within Colab, right? So here on the top right, you see Gemini. You can either click on this and you can chat about your code with Gemini, or this is a cool feature. You see this next steps and it says explain error, right?
Yeah.
This actually kind of like takes this error and shares with Gemini and asks, hey, how do I fix this? So let's try this. So it tells that, and then Gemini is thinking, and it thinks about, and it explains like what hypothesis it has. uh, you know so it says that, hey, the traceback shows the error originating within tokenizer. um, it seems like the issue lies with the texts variable, which is, right here. um, so it's possible that, so it comes to two conclusions: elements in text
Okay.
are not strings, you know or there is a next nested list structure. So in any ways, what it asks to do is to convert every element of the list text to a string,
So string.
right? So let's try and do that. You can take this, and where is it? Yeah. All right. So now let's see how it works. Okay. So now we have a much clearer um, list.
Like yeah, like we now have the whole data in string that
Mhm.
make it easy for us to use. Yeah.
Yep. But let me just actually uh, see what the size is, because, oops, length, I guess.
Yeah, I was a bit confused when you wrote lens.
Yeah. I mean, there are so many different ways to do it in different languages. Sometimes I get confused, right? Which method to use where. But yeah, Python definitely has len. All right. So now we have the texts. Um, let's see the results. This time, hopefully, it works. So what it's basically doing is, it was already a string of list of strings,
Yeah.
but I think because of some emojis, so there are some emojis, right? For example, this
Yeah.
review is just emojis. There is no text in it, so that's where I think the problem was. So that's why it's going through each of the text and then converting it specifically to string. So these emojis are going to be converted to their, respective Unicode representations.
Oh,
So, all right.
so it means that the analysis tool also take note of emojis as um it also take note of emojis when creating the feedback, like if it's positive, negative, or neutral.
Yeah, I think so. I think so. So, because we're using the transformer model, and transformer models are trained on, huge corpus of data from the internet, and on the internet there are like emojis everywhere. I believe that it should be able to understand what is the difference between heart emojis and whatnot. But here is the problem. You see, this score is not really well represented, even in the data set, right? So that's where the quality of the data itself matters. For example, here in this review, the review itself is like heart emojis, right? But the score given by the user is one, which is very negative review, right? So
Yeah,
these kind of reviews can confuse the model, and it does not really reflect well. So that's where like a data quality actually really comes into play, where, you know there is a saying in the data science and machine learning world is, um, crap in, crap out, right? So
crapping
so
about.
so if your data is not good, you cannot expect the model to work well, right? Hopefully here in this data set there are only few examples like this, but we're going to find out. We're going to find out. So we get the results. Now results are essentially just a bunch of labels and the scores, right? Why? Because we are, where's the pipeline? Yeah. So we are using this pipeline, and we are, passing the text, and what it does is it returns the label and the score. Like, again, the score is like the polarity, right, which we saw earlier in the previous example when we were doing earlier, right?
Yeah,
The closer it is to one, the better. And then the closer it is to, I think, zero, the negative. But yeah. So let's hide this for now. All right, so we have our results, but you cannot really understand much from these results. So what we're going to do is we're going to print, for, let's say, text, um, result, and score in zip texts, results, and df dot score dot values. Um, so what we're doing is we are taking the texts which we entered from the data frame. We are taking the results which we got, and just to show like the compare what this score is, um,
okay.
we are going to just print them side by side. Oops, my bad. Print text, and then print the result and print the score, and then, yep. So this is much better, right? This is much easier to understand. Uh,
Yeah.
so let's see. Here, the text input text is whatever the review that is, two hard
Too
levels.
hard.
Our model predicted that it's a negative review. And this score, okay, so this score is not actually polarity, this is the confidence score. So that means the model is very, very confident. So the closer to one, the more confident the model is. So this says that
Oh,
model is very confident that this is a negative review, right? And this score is directly taken from the data set. So that means the person who wrote this review gave the score of one, and we also predicted that it's a negative. So, right, so that means that we predicted correct here. Here also, the person who gave the review good uh, gave it 5 star, and we also predicted that, hey, this is a
positive.
positive review, right? And the model
Oh,
was very
I
confident.
see. Yeah, sorry for cutting you short. Yeah, I see that it also predicted the sentiment level for the emoji.
Mhm.
Just
Yeah.
below, yes.
Yes. So It did that, but focus on the score here. So this, it's not very confident that it's a negative score,
Okay.
right? So it's, so zero point 0.9 is like very close to 1. That means it's very confident that this particular review is positive. But since this is an emoji, it's not very confident. So it did say that it's negative score, it's a negative review, but it's not very confident in its output, right? So it's only zero point 0.6, which is almost like 60, it's almost 70% sure that it's a negative review, right? Whereas here it's 99% sure that it's a positive review. So that is something that, I think it struggles with, is with emojis. And also it's a emoji, I feel like it's a good emoji, but the score is only 2. So that also could have played into, it getting confused and not having like a good confidence here. uh, but yeah, there's multiple things to be considered here, right?
Yeah.
Yeah. And for example, this one, it's a very long text, right? Every level is either hard up to impossible to win without spending money. I get it that it's the whole point, blah 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 blah. So it's a pretty long text, and our model actually correctly detects that this is a negative review, and it is also pretty confident here, right? 98%, which is pretty good, and the review also is given 1 star. So you can see like um, how this works. Now this is some Gen Z language right here.
I was
Pizza.
just gonna ask. I I was just going to ask that.
So
What if the your sentiment analysis to need to search through the feedback of Gen Z and Gen X, and obviously we know that Gen X, their reviews are more easy for the model to
mhm,
understand,
yeah,
and the Gen Z reviews would not be as easy for the model to understand. And this is just a good example of that.
exactly, yeah, right. So even the AI is not sure what these Gen Z people are talking about, but right. So I mean, yeah, it says that its score is 5, but the model is like, maybe, But anyway, yeah. So yeah, so this is like too much for the model, also. Like, what are you talking about? The model is like, hey, this looks like it's negative to me. Uh,
Like there's so many emojis.
yeah. So even the AI is like, I'm done with humans.
Like
But
bro.
yeah. So, so yeah. So I mean, this is a good way to kind of like see how our model actually is performing. But an even better way is, let me just hide this, is to directly compare in the data frame itself, right? So you can write, so we are going to add this sentiment, the result, as a column in this data set itself. So on the, you'll see the score, you'll see the content, and on the right hand side you'll also see another column which says it's a positive or negative as predicted by us. So
Yeah.
you add a column by doing this. So df, and then using the square braces you add whatever the column name is, and whatever goes in the column you're going to pass it right here. So you're going to add a list to this column, right? And whatever you're going to pass is, from our result you're going to pass the labels, right? So you take that, you use a list comprehension here because this makes it much easier. You can also use like a normal for loop as well, but this is much better to use here. So you take the results, you take each result one by one, and you take the label, because remember the result has label and score, right?
Yeah.
So you take the label from the result and you add it to the sentiment column. So earlier our data frame had only review ID, content, score, but now we will have the review ID, content, score, and the sentiment which we predicted, right? So we just added this, took this from the result and added it to the data frame itself, and now you can see, kind of compare directly, what the user uh, gave, what the rating that the user gave, and versus whatever the sentiment that we predicted, which is almost, it's close enough. It's close enough. Uh, so yeah. it works. Um, so yeah, this was sentiment analysis using two different methods. The first method
Wow.
is much more classical, where you don't really use like a lot of transformers. It does, the basic uh, text modifications. Basically, behind the scene, the developers have implemented the ways to modify this text, divide this text, and understand what each word means and things like that. But here in this case, we're using the transformer model, and specifically, we are using the BERT model, which, as I explained in the beginning, BERT is the model which is really good at natural language understanding tasks, because it, you know, understands or reads the text both from left to right and right to left. Um, and that's why it's bidirectional. Um, and it's specifically made for these kind of things, so it's made for, you can do sentiment analysis with it. You can even do like uh, topic extraction. So if you pass like a huge chunk of text, it can understand what is the topic of this text and can, like, output, hey, this text is about this. So it's very good at understanding related tasks, whereas GPT is really good at doing, generation task and basically doing like chat and stuff. So
Wow.
yeah, these were the couple of ways to do sentiment analysis. If you want, I can actually share this notebook as
Wow.
well in the chat for, if someone wants to follow this. Um, let's see
Oh
how to
yeah, please do.
do that.
I am just blown by this.
Yeah, it's pretty exciting. Let's see. Anyone with the link is a viewer, sure. And let me copy the link, and let me share this in the chat, and you can share this. Uh,
Awesome. And I will also be including this in the video description. So if you are watching this and you need to get the source code for this sentiment analysis, you can find it in the video description. So, in your opinion, do you think that the first way of building the sentiment analysis, that's using the text blob, is better or more accurate than using the transformers, or vice versa?
that's a good question. So it really depends on what kind of um, use case you have. Right, transformers are actually huge models, and uh, you need to host them somewhere, right? So if, for example, um, if you are making a project, it's
Okay.
good, right? It's good to use transformers. You can put it in your resume and things like that. But in a company, if you're working, right, if you're working in a company, and uh, this kind of question arises that, hey, whether we should use text blob for our product or should we use transformers, it depends on what are the priorities of the company. Is the company open to hosting their model in their own servers, or are they okay with, this model being, um, I don't know, like hosted on some other server by, let's say, Hugging Face or AWS or things like that. And again, a lot of different things come into play where, um, if you have huge amounts of text that are coming in,
Yeah.
it will be it will be hard to keep text blob uh, up to date, where, it has only specific strict guidelines behind the scenes according to which it operates, and you only have so much flexibility with text blob, right? You can set a threshold. I think there's a couple of more attributes that you can play with, but that's kind of it. It's Text blob is really good at basic use cases, uh, but if you want to do like complex analysis of text, not just sentiment analysis but any kind of other analysis as well, and try to get a lot from any kind of, feedback or any kind of text that you're getting as a data from the users, transformers is one of the best ways to work with that data, especially if it's like huge data, right? um, but also these results do take some time to come up, right? So you saw that when I ran this, when I ran this pipeline, it took some time to go through
Yeah.
all this text and process them and give the results. So if you have like millions of rows, if you have like millions or maybe billions of rows, if it's a huge company, um, that might be something that you should take into account, where it takes a lot of time, whether whereas the text blob could probably do it quicker, but again you don't have as much flexibility. So there are some trade-off in both of them. uh, it really depends again.
Oh, I see, I see, I see. So, but is there any like
Oh, I'm going to, sorry, I'm going to just stop sharing.
okay, yeah.
Yeah.
So is there any would I say easier way or shorter way to let to do this analysis if the okay, if I'm dealing with millions or billions of rows, billion rows of data, is there an easier way for me to do this? Like, do I divide it into chunks or
Mhm.
do I do everything at once?
Yeah, so usually what happens is, when you have such a huge amount of data, you you have to divide it into multiple chunks. That is
Okay.
something that you have to do, because otherwise, um, it becomes really hard to first of all ingest the data, right? If you are taking all of that data one go, um, it's going to stress your servers a lot. It's going to take a lot of time to process, right? And in the end, you are not going to be able to quickly iterate on that. Whereas if you keep this data and distribute it in chunks, and have your model also like deployed in a distributed environment, that
Okay.
is going to allow you to iterate faster. Your servers are going to be happy, and it's just much easier and quicker to do that. So definitely, yeah, if you have such a huge amount of data, then dividing into chunks is the way to go. Distributed computing, all the way.
Wow. That's awesome. Wow. For real, I really love this coding session. I think this is like the second time that I'm really understanding how notebook works and how data analysis works.
Perfect. Yeah, I mean, I'm really happy that you have invited me, and honestly, I really love um, doing these kind of live stream or spaces or anything, because I really love sharing anything that I have, any knowledge that I have, and I'm just really glad to do that. Uh, right, even from college, um, I had a couple of seniors in my college, during my undergrad, which did that
Yeah.
and inspired me to do this, and that's why kind of I'm doing that, and I'm loving it. So I'm really happy that you are also loving it, and hopefully the users who are watching this also love this.
Yeah, definitely. I mean, okay, now before this chat, I was not a huge fan of the data analysts or data analysis in general because I didn't quite understand what they did. Of course, I knew that they analyzed data, but I didn't quite understand why they need to analyze the data or how they analyze the data. It's with this demo of the sentiment analysis, now I have an understanding of how that would work. So before we hop up, another question I do have is, in what scenario do you think that building a sentiment analysis would be useful?
Yeah, definitely. So as I was talking about in the beginning, right? One of the best places to include this in your, either workplace or whatever the projects that you're building, or even like in a hackathon, just adding this one feature of
Yeah.
sentiment analysis in, let's say, um, any kind of a chatbot, or any way that you are collecting feedback from the user. Just adding this one feature in the backend makes it so much easy to understand where your product stands, and how people are, kind of like, how people are interacting, and how they feel about it, essentially, right? That is one of the easiest places to first start with this, and build it and include it in your own products or projects that you're working on. Because just having like standalone, just what I did today, it's not really useful in its on its own, right? I mean, okay,
Yeah.
so I can predict that a text is positive and negative, but what do I do with it, right? um, but feedback, understanding feedback, that is one of the places where, it's actually really valuable for companies, to understand, like, what their users think. So that is one of the places. Another one could be, if another one could be like for content moderation, let's say,
Okay.
right? So let's say if you are working for a company which, has this platform, and a lot of people interact with it, and you want to automate the content moderation and things like that, you can use a version of what we did today, where instead of having, positive, negative, and neutral, you can have like a different set of classes, right? So these could be like something going from obscene, or, nsfw, whatever, all these kind of classifications you can have, and then block anything that goes onto that platform which classifies as such. So there are a lot of different use cases, and a lot of different ways which you can use this kind of sentiment analysis model.
Awesome. Wow. This is amazing. This is amazing. And I would definitely love to do this sometime again because I mean, I'm learning a lot of analysis from you. Like, I'm really learning a lot about data analysis, data science, and machine learning. That reminds me, please, is there any notable difference between data analysis and data science?
Yes, so data analysis is kind of like a part of data science. Uh, so data science is like a huge field. It includes it. Data science basically, it starts from, data collection of data, and then performing analysis on data, and then, modifying the data to suit the model, and then training the model, and, deploying the model. Everything. It's like the entire thing is comes under data science. Whereas data
Yeah.
analysis is just, when you have the data, you have to understand it first before, you can do anything with it. So
Yeah.
that understanding part is what data analysis is for. Data analysis allows you to see what is the data type, what kind of, let's say if it's a tabular data, then what kind of columns does this data have. For each column, let's say you have like multiple values. So in data analysis, you'll even deep diver, and then you'll see like, out of all these, let's say there are five different values, like in our case, let's say ratings, right? The score. So there's one,
Yeah.
two, three, four, 5 stars. You might want to go ahead and analyze how much of the data, let's say out of 100%, how much of the data is 5-star reviews, right? Let's say 60% is 5-star
Okay.
reviews, 40% is 3-star reviews, something like that. So you want to understand the data to kind of like understand, hey, this data is too much skewed towards 5-star reviews, right? We don't really have any 1-star reviews. So we might want to either modify the data set and manually include some 1-star reviews, or we will discard this data set and use something else which actually has 1-star reviews, because without seeing that, the model will not be able to, learn from those things. So this is where data analysis actually comes into play, right? So basically understand what kind of data you have, and then act accordingly and modify the data accordingly, so that your model has the best data quality. that goes in.
Oh, wow. Finally, I now understand the difference between those two terms.
Perfect, perfect.
Well, thank you. It's really been fun to have you here demo and really educate me on data analysis, and because now I can brag that I mean I know how to create a sentiment analysis using text flow, and I can also do that using the transformer. So I can brag about that now.
Yeah, for sure. Using transformers is not as difficult as many people think.
Yeah, it's not. To be honest, it's really, really, really not. So, so thank you once again, and let me know if you would really love to do this some other time. And so everyone that is watching or would watch much later, um, thank you for sticking till the end, and I hope that I was not the only one that will be leaving this chat with so many insights on data analysis. So if you do enjoy this chats, do well to subscribe, and you can also leave in the comments who you would love me to have a live chat next. And if you still have a topic in mind relating to Python, because right now my focus for the channel is on Python. So if you still have a topic um, that you want an EMA on that is relating to Python, you can also leave that in the comments. And if you have any guest in mind, you can also leave that in the comments and I will try to reach out to them. So till next time.